How you doing today? Today we're going to be working on a 2000 Toyota Avalon. Like a lot of these 3-liter V6 Toyotas, we've got a NOx sensor code coming up. It comes up as P325 and also P330. P325 is the NOx sensor number 1 and 330 is NOx sensor number 2. It's very, very common on these that one or the other goes. Sometimes in this case both are gone. They're most often diagnosed as the NOx sensor being at fault, but from my research online and from talking to other Toyota mechanics, it's almost never the actual sensor that's at fault. It's the wire that leads to the sensor, so a shielded wire. So I've got a couple here that I picked up from the auto wreckers. This is the wire in question, okay, and with the NOx sensors attached to it still. And this is buried underneath the intake manifold in the engine, so it's in a very, very hot place, and the wires eventually deteriorate. And they're very, very sensitive to radio frequencies and whatnot, so it's a shielded wire, and often it's the shielding that actually deteriorates and it starts tripping false codes. It says it's got a NOx sensor problem when in fact it doesn't. It's not the NOx sensors, it's the wires, the circuit that's failing. The check engine light comes on. If you had the vehicle stability control, that automatically comes on whenever the check engine light comes on, and the engine starts to depower. You can actually feel the engine has less power, and sometimes you feel a bit of a vibration. There's not much harm in actually driving like that for a while, but of course you'll never pass your emissions test like that. This one is another one I got from the wreckers, and again you can see how brittle the casing is. It's quite literally cracking and breaking. So it's got to be replaced. Okay, from Rock Auto, a new wire is 24 bucks. Okay, the problem is it's a lot of work to get to it. Okay, there is no real definitive test to check whether you have a defective sensor or not. In this case, we're going to risk leaving the old sensors in place because quality brand sensors are running at between $60 and $100 each. There's 2 of them. And if you replace them and they're not needed, that's 200 bucks gone to waste. If, of course, I'm mistaken and the sensor is bad, then we got to do the job again. And doing the job again, of course, entails a lot more work and a number of gaskets that have to be replaced. We picked up a gasket kit from Rock Auto as well. We got a little lucky this time because they had a complete head gasket kit. It was actually less expensive than buying the individual components we needed. So we'll have gaskets left over, but the price was right, so we got it. Okay, Felpro is a pretty reputable brand. OEM is obviously a good brand. I would suggest stay away from the cheapy stuff because you may end up regretting that later on. We're going to be taking the intake manifold off and the plenum off, and if they start to leak, air leaks get in there, starts throwing your air-fuel mixture off, and can cause all kinds of problems in the future. Okay, we're going to be using our Haynes manual. We're going to try to follow it step by step as close as humanly possible so you guys can follow along in your own manual. If you have a Chilton's manual, Chilton and Haynes own each other. They are word for word the same. The pictures are even the same. Everything is exactly the same. Don't waste your money buying both like I did because they are quite literally the exact same manual published by the same publisher. Okay, so we're going to follow that right along step by step. Okay. Not related directly to this problem, we have an issue with the rad that was cracked. We sealed it up temporarily with epoxy. So as part of this procedure, we're going to be changing out the rad. It's unrelated, you don't need to do that, but we're going to be doing that. And we're also going to change a fuel filter. We picked up a fuel filter, again, it's unrelated, but we're going to do that too. Okay. There's a lot of people who recommend, while we have it all apart, that we change this coolant hose. This is again one I got from the wreckers. This is buried inside the engine. When we have the we have the intake manifold off, you'll be able to see that. It's not a bad idea to change it. They're not expensive, so you can go ahead and do that as well if you like. We're going to be changing rocker cover gaskets because we have some minor oil leaks there. Much easier when it's all off. If you need a tune-up, it's a lot easier to get to the back spark plugs when we have this all off, so it's a good thing to combine. It's not necessary to take off the plenum to get to the back spark plugs. It is a bit of a challenge to get to the spark plugs, but if you have it off anyways and you're due for a tune-up, may as well bang in a set of plugs while you're at it. Another thing that's easy to get to when you have the plenum off, and a real bugger when it's not off, is the rear air fuel mixture sensor. Okay, it looks like an oxygen sensor, but it's not. It's not an oxygen sensor. It's much more precise than a regular oxygen sensor. Most parts places are selling oxygen sensors in place of the air fuel sensor, telling you, oh yeah, it's the same thing. It's not. It'll give you grief down the road. So make sure you get a proper one. You stick with the Denso, the ones that Toyota puts in there in the first place, you really can't go wrong. They are a few bucks more, but if you shop on Amazon or Rock Auto, they're cheaper than going through the dealer. Okay, and of course, if you have a good relationship with the dealer, then you can perhaps get a decent price from them too. But better stick with OEM parts for that. Okay, but again, if you have this intake plenum off, it's a good time to tackle a few other jobs that maybe you've been postponing doing. Okay, so let's take a look over at the car. Okay, we're going to be draining out the coolant here momentarily. If you notice, we got our drain bucket already down there, set to go. We already have the plastic cover off the top of the engine, so you can see what we're going to be digging into. Basically, everything on this top, everything here from the throttle bodies, all this section, everything has to come off. All right, it's quite a labor-intensive job. Not really a lot of mechanical skill required. You do need a couple of basic tools. We have a good set of sockets over here. Hand tools are all you really need. I do have the benefit of air tools, which I'll be using too, but most important thing that you may have to purchase or at least rent is a good quality torque wrench. Okay, this is an essential tool that you have to have before you start. Borrow one, beg, whatever you got to do to get one, but you cannot do this job without one. Okay, make sure you pick up a good torque wrench somewhere along the line. Okay, they're not that expensive. On Father's Day you can tell the kids that you need one. So, all right. So we're going to get a start. We'll find the section in the manual, and we'll literally go through it step by step as we go along. Okay, we're going to be cutting and starting and stopping the video because you don't really want to see me turn wrenches for 4 or 5 hours. All right, thanks. So what we're going to do, the first step the book recommends is testing the sensors. Okay, we've got a couple here from the records we're going to test just to show how it's done. The meter is set to ohms. It shows 1 when there's no continuity, and it should show 0 when the terminals are crossed. Okay, the only test it can show you, or the only test the book says to test these sensors, is to put your probe up against the casing of the sensor and test by touching the center terminal and making sure that it still shows 1 on your gauge. It does not go to 0 or any other number. That means there's no continuity between the internals and the casing. Okay, now that is an important test to do because that will confirm your sensor is bad if it does give you a number. Unfortunately, it does not confirm that the sensor is good. Okay, the way that these sensors work is when it reaches a certain vibration, I believe it's 9,500 hertz, the sensor generates an AC signal that is sent to the computer. There is no signal any other time. Okay, so the only way that you could really test that sensor is to expose it to 9,500 hertz vibration, and then it would send out an AC signal, just a milliamp signal. Unfortunately, I don't know of any way that you could do that. So we're kind of out of luck. On some model cars, from what I understand, it does not apply to these ones, but with some model cars what you can do is run the car, pull the fuel injection relay out. The car will start to stutter and stall when it runs out of fuel, and just as it's stalling, it should trip the knock sensor. It should generate a signal. So if you're working on a car where you can get to the sensor while it's running, you can try that. Pull the fuel injection relay, let it stall with your gauge ready to go, and see if it sends off an AC signal. Unfortunately, these ones are buried inside the engine. You cannot get to it, so you can't do that test on it. Okay? So it tells us the first step in doing the replacement of the knock sensor is to wait for the car to cool, and then to disconnect the battery negative from the battery. It also warns us to make sure that if we have an anti-theft radio interlock system, that we know the code before we disconnect the battery. This car doesn't have that, but if your car does, make sure you know the code, because otherwise you won't be able to get your radio to work after you're finished. Kind of important. Taking off the battery is kind of a first basic step on a lot of jobs, because we are dealing with electrical items. We don't want any chances of short circuits or anything happening during the job. So that'll be our first step. Okay, so next step is to drain the radiator coolant. We will be losing all the coolant out of the engine while we're doing this job. The drain tap on this car is right down at the bottom here. If you see where my rod is pointing, it's way down there. We got a still snap for you of the new rad. It's a lot easier to see on the new rad than it is in the picture here. Those little drain taps are sometimes fairly tight, so a little pair of pliers just to give it a little twist might be helpful. It's an awkward spot to get to, but it's got to be done. So we get that coolant out of there. Okay, so the next step, it says on V6 engines, remove the intake manifold. Sounds easy, but it is not. There's a whole bunch of steps involved. Okay, so it says refer to chapter 2.6. So we gotta go over to 2.6 and then we start our intake manifold removal procedure. Okay, the next step is to relieve the fuel pressure, because we're going to be disconnecting the fuel injectors, and in this case we're also going to be changing the fuel filter anyways. The book suggests that you remove the rear seat bottom, which is a fairly easy task. You just simply pry up on the front of the seat and then pull the seat forwards and it comes out. Then you have to disconnect the fuel pump, and they tell you to run the engine, disconnect the fuel pump, and the engine will stall when it's out of fuel, so no fuel pressure left. Of course, they tell you that after you've already disconnected the battery, so nicely done, guys, put it in order. From my experience, there's very little fuel is going to get spilt here. We're going to be careful and use some rags to soak up any fuel that is spilt. We're going to crack open the fuel system at a different point to let the fuel pressure relieve that way. Do it in an open area, obviously. Obviously don't smoke. You don't want to be sucking those fumes in. It is bad for your skin, so don't let it get in contact with your skin either. Okay? Good. Okay. Okay, so the next thing we've done now, we've got the fuel pressure relieved, is now we're going to start to remove major components so we can get to the intake. Okay, so we're going to be taking off this entire air intake system right through the plenum, right down into the intake manifold. We're going to start right here at the air filter. We got a couple of clips there that we've taken off. Okay, so clip down here. Nope, actually it's not. These ones just flip out. Sorry. Okay, there we go. Now we're going to take things off, and I don't really worry too much about labeling every part because I know what it is. It's not a bad practice to put a little piece of tape on every hose that you take off, every wire connector you take off. Put a piece of tape on both the hose and the side where it attaches to. If you know what it's called, you can write the name on it. I just put 1, 2, 3 so that I know where to put the parts back on later. Okay. Nice thing about Toyotas is that most of the electrical connectors and whatnot will not fit any way except the right way, so it's pretty tough to screw up. But if you label them as you go along and you put them back on in the same order that you took them off, 1, 2, 3, 4, then you know that you haven't missed anything. Okay, so we're going to take off our air filter. Okay, you see the air filter housing is attached to the throttle body by these two hoses, so we're going to take off those two clamps there. This hose going to the rocker cover's got to come off. Okay, there's a number of smaller hoses and wires which we will take off as we go along. Okay, so we have most of the vacuum hoses off, the electrical connectors off. You've seen the still pictures, I guess, of all the different hoses. I don't know which one's which, it doesn't matter, just put a number on it. That way you know where it goes when you're done with it later. Electrical connectors, like I said, on Toyotas almost always just fit one way. You can't go too bad with that anyways. Otherwise, number them too. We're now going to take off the throttle linkage. Easiest way to do this is just to disconnect the cables. Okay, just give it a quick turn like that. Try not to move the nuts too far from their normal position so that when you put it back in, the adjustment on the cable will be good. You don't want to have to move it too much. Okay, so all the turning I'm doing is on this one side, so that when I tighten it, I know to tighten this side. And then I won't have to worry about my adjustment being off. A little dab of anti-seize grease is going on all these bolts when we put it back together. It's just like a bicycle brake cable. It's got a little tab on the end. Get it to come out. There you go, just like that. Okay, so we just set it aside. Okay, now again, Toyota does things quite intelligently. They use different sizes. This is a 12, this is a 14. They won't fit the wrong way, but not a bad idea to label them just so you're not messing around. Okay, the book tells us the next step is to take the plenum off, which is held on by a couple of bolts. And there's one bolt, if you've done any reading on this job before, it's a royal pain to say the least. Okay, it's a brace that's on the back of the plenum. It supports the weight of the plenum at the back, and it's held in with one little 14 mil bolt. Doesn't look like much, but this is the royal pain in the butt on this whole job. Okay, the bolt is approximately right down here, okay, in behind the plenum. The problem with it is that there's not enough room between the firewall and the bolt head to put a normal socket wrench on. Okay, you can try any combination of wrenches, and you cannot get on it because there's a brace for the power steering line that sits right there. It prevents your wrench from getting on. Okay, so no matter what you try, you cannot get on that with a normal wrench. Okay, I was successful with this wrench. It's an offset 14 millimeter. Sorry, this is the 14. Okay, and you have to turn it about a 1/16 of a turn at a time to get it off. It did succeed. Putting it back in, on the other hand, is another royal pain. There's actually been YouTube videos on how to put that bolt back in. And the problem is with the Avalons, more so than the Camrys and Siennas, is there's just not enough room by that firewall to get to this. So later on, I'll show you when I have it all apart. I'll show you where that is, and I'll show you what I'm going to try to do. This will be a first time for me. I'm going to try to replace this bolt with a stud and then a nut. So the stud will be in there, the brace will go on, and then we'll put the nut on afterwards. Trying to get the bolt started is the problem when you're trying to put it back in, because you can't get it aligned right, and you're screwing into aluminum, so if you miss it, you cross thread it, it's not going to work anymore. So many mechanics I know of just simply leave this bolt out altogether. I don't really agree with that, but it's very common practice and the customer never knows. Alright, so I'll show that more to you later on. Okay, so we've got the intake plenum off now. It's still connected to the throttle body. There's no need to disconnect that if you don't wish to. We're just cleaning out some of the carbon buildup on the plenum there. A little bit of optional stuff. If you want to switch our attention over here, we're now ready to start on the intake manifold. Okay, the intake manifold is this whole section under here. Okay, we have the fuel injection rails we still need to take off. This is the plenum gasket. We're going to be replacing that. Okay, so we're going to take this section off next, and our NOx sensors are just underneath here. So we're about 75% of the way in the dismantling part now. Okay, so if you're following along in our Haynes manual, we're now at this part where it says lower intake manifold right here. Okay, and it says to disconnect all the fuel injectors and disconnect the air assist and heater hoses. All right, we've already drained the coolant, so we can disconnect that as well. We've already drained the fuel pressure, so that's ready to come apart now. Okay, so we're going to take off each of the 6 fuel injector connectors. Be careful, the plastic does get brittle with age. Okay, so squeeze the tab and pull. It says, there we go. Okay, so those are all clear now. Now we take the injector rails off. Okay, so we have the offending wire out of the car. Okay, visually there's not much wrong with it. We've checked the continuity on it. It appears okay. We're kind of going on faith that this is in fact what the problem is. Okay, we did check both the knock sensors as I showed you before. There's no continuity between the center terminal and the ground. So we're just hoping that our friendly Toyota mechanic who said that they never fail is correct, and we're going to go with changing just the wire. What I can tell you is that the new harness, the cable is much more flexible. The old one is quite brittle and cracks and creaks every time we try to move it. It's obviously had way too much heat in its life, so let's hope that is in fact the problem. You'll notice that there's a number 1 written on one of the 2 sensor connectors. The replacement one has a little tag. It reflects the same thing. It doesn't have a number on it, but it's tagged. You'll notice it's the shorter of the 2 wires. Okay, that's for bank number 1. You cannot accidentally put it on wrong because it won't reach the wrong one. Okay, so let's just make sure you put it back together the right way because it will affect the future code readings if somehow you manage to mix them up. Okay. So this is the intake plenum. We've cleaned it up and it's just about ready to go on now. This is the bolt that gives everybody grief going back on when we're trying to do this job. So many people end up giving up on it because there's just no room to get your hands in between the brace that I was pointing out in that still picture a moment ago. You just can't get that silly thing lined up, and it's aluminum, so you usually end up stripping it if it's misaligned. Okay, so what we've done, instead of using the factory bolt, we've got a stud. Same thread. What we actually ended up doing, because we couldn't find a stud at the store, we ended up just taking the scrap bolt that we had, metric bolt, and cut the head off of it, put a little slot in the end to make it easier, and that's going to go in here, and we're going to put a nut on the end. Okay, so I'm going to put just a little bit of Loctite on it. That will stop the snip from coming undone in the future. Okay, just screw that in there. Okay. We've cut a little slot in the end for ease of installation. Make that nice and tight. Okay. And then we're going to put a nut on there. And we're going to put a little bit of anti-seize grease on there too, so that in the future when we're trying to take this off, the nut with the anti-seize will come off easier than the stud that's Loctited in there. That stud can still come out, but it's going to require a lot more force. Okay. This should make putting it all back together a whole lot easier. So that little stud trick on the back of the intake plenum worked great. Fantastic. It just slipped right in. The nut went on fairly easily. The tightening of it was a little bit of a pain still because there's not much room for your socket wrench in there. A lot of people online are suggesting using a kind of a pass-through socket. There's a number of brands out there that work, which is good. One thing that I could have or should have mentioned was there's a ground strap right beside that. It's a little 10mm bolt that holds it on. That's easier to put on before you put the intake into place. So you want to put that wire on first, tighten it up, put the stud through the hole, put the nut on, and then finally put the 4 bolts in the top of the intake plenum and torque them down. Another thing I failed to mention was that when you're torquing it, those intake manifolds don't take much torque. It's 320 inch-pounds. Okay, that's not very much. So you have to first of all make sure you have an inch-pound torque wrench, as well as your foot-pound torque wrench for other components. Okay, so you can see we have the engine back together again for the most part. All the hoses and wires and everything are put back on. One thing that the book failed to mention was that this part here that the upper rad hose attaches to and your rad cap's on, it has to come off as well in order to change the intake manifold gaskets. They missed that on the Haynes manual. So again, make sure you clean that up real carefully and torque it. There's no spec given in the book. I use the same spec as the intake manifold, the 320 inch-pounds. All right, so all we have left to do here is we got to put the rad back in since we were changing it as well, and then we're finished for this job. I hope you enjoyed it, got something out of it, and we'll talk to you next time.